Good day. I will now discuss to you the third equation of lines in space, which we call it as symmetric equation of a line. By definition, symmetric equation of a line, if all the coefficients a, b, and c in the parametric equations x equals x sub 0 plus at, y equals y sub 0 plus bt, and z equals z sub 0 plus ct are non-zero, then the parameter t can be eliminated. Solving each equation for t, then set the resulting equation equal to each other. This gives x minus x sub 0 over a is equal to y minus y sub 0 over b equals z minus z sub 0 over c, called the symmetric equations of the line L. Take note that if one or more of a or b or c is 0, then the line L lies in a plane parallel to one of the coordinate planes. In this case, the line does not have symmetric equation. Let us work on this example. It says here, write both parametric and symmetric equations for the lines through point P, whose coordinates are 2, 5, negative 7, and point Q, whose coordinates are 4, 3, 8. Find also the points at which the line intersects the three coordinate planes. Let us again recall the formula for parametric and symmetric equation for the line. So we have here, for the parametric equation of your line L, we have x equals x sub 0 plus at, y equals y sub 0 plus bt, and lastly, z equals z sub 0 plus ct. So we call this as parametric equation of a line. Then we have the symmetric equation of your line L. For the symmetric equation of your line L, we have the formula, which is x minus x sub 0 over a is equal to y minus y sub 0 over b is equal to z minus z sub 0 over c. So looking now at our given problem, so we have here 2 points, P and Q. So if we have now to draw these 2 points in the three-dimensional space, so we have here x, y, z axis. And let us assume that this is your point P, and we have this as point Q. So to find now the parametric equation of your line L, as well as the symmetric equation of your line L, so let us find first the vector V, where we can define the components of your vector with coordinates A, B, C. And that is, it can be obtained from vector PQ, and this will be our vector V. So with that, we can now have the terminal minus the initial point of your line L, and that will be 4 minus 2 is 2, 3 minus 5 is negative 2, then 8 minus minus 7, that will be 15. And using now our initial point to be P, so the parametric equation of your line L will be equal to we have x is equal to x sub 0, where x sub 0 is, we have it as from the coordinates of your point P, which is 2, then plus we have your a from your vector v, so that is 2 plus 2t. Then you have y equals yo, which is 5. Then you have your b, which is negative 2t. Then we have z equals, z sub 0 is negative 7. Then you have plus ct, so you have c equals 15t. So this is the parametric equation of your line L. For the symmetric equation of your line L, we now have this formula to be used, which we have now x minus x sub 0 is 2 all over a, which is 2, is equal to y minus yo, which is 5, all over b, b is negative 2, is equal to z minus z sub 0 is negative 7, so that will be positive 7 all over c, and c is equal to 15. So we have this now as the symmetric equation of your line L. So let us now find the points at which the line intersects the three coordinate planes. So we will use this parametric equation of your line L. So we have intersection of the line at xy plane. So we have intersection of your line L at xy plane. So we're going to set z equals 0. So as I've mentioned, using this parametric equation of your line L and setting z equals 0 in the third equation, we can solve for t. So that means we have 0 equals negative 7 plus 15t, and t will have value of 7 over 15. Then substituting now this value of t in your x and y in these two equations, we can now solve for x and y. So with that, x is equal to 2 plus 2 times 7 over 15. So this will give us value of x is equal to 44 over 15. Then the value for y, substituting t equals 7 over 15, that will be 5 minus 2 times 7 over 15. That will give you 61 over 15. So therefore, the intersection of your line L at xy plane, when z is 0, so the point is at x is 44 over 15, y is 61 over 15, and z is equal to 0. Next, let us get the intersection of line L at xy plane or in the xy plane. So with that, we're going to set y equals 0. So solving for t, so we're going to set y equals 0. Solving for t here, so t would be equal to, you have 5 over 2. And substituting t t equals 5 over 2 in your first equation and in your third equation of the parametric equation of your line L. So solving for x, that will be equal to 2 plus 2 times 5 halves will give you equal to 7. Then for y, you have 5 minus 2 times 5 halves, or rather we're going to make use of the z because y is 0. Z equals negative 7 plus 15 times t, which is 5 halves. So this negative 7 plus 15 times 5 halves, the answer is 61 over 2. So therefore, the intersection of your line L in the XZ plane is, let's call this as point Q, whose coordinates we have it at 7, 0, and 61 over 2. Then lastly, let us get intersection of our line L in the YZ plane. So in this case, we're going to set x equals 0. So if x is 0, our t value will be equal to negative 1. Then substituting t equals negative 1 in your second equation and third equation of the parametric equation of your line L. So y equals 5 minus 2 times negative 1. The answer will be 7. Then you have z is equal to negative 7 plus 15 times negative 1. This will be equal to negative 22. So let us call this as point R. So the coordinates of your point R, which is the intersection of your line L in the YZ plane, so we have it as x equals 0, then y is 7, then z is equal to negative 22. So these are the points at which the line L intersects the three coordinate planes.